In this video, we will understand the meaning of electronegativity, non-polar bond, polar bond, and dipole. We will also understand the difference between electronegativity and electron affinity with the help of examples. We will also do lots of practice problems and interactive quizzes so that you can perform really well on your exam. Towards the end of the video, I will also give you some bonus tips and tricks to solve problems for your examination. In the introductory part of the lecture, we will understand what is a non-polar bond, what is a polar bond, and what is the meaning of electronegativity. Starting with a very simple example of hydrogen molecule. In hydrogen molecule, each hydrogen atom have one valence electron. They share their valence electrons to form a chemical bond, a covalent bond. The shared pair of electrons is present in the center of the nuclei of hydrogen atoms. Both hydrogen atoms are identical, so their nuclei are also identical. It means they have same charges. Now, these two nuclei are going to exert the same attractive forces on the shared pair of electrons. So, the shared pair of electrons are going to spend equal time near each nuclei. Due to this, there is no charge separation and hence hydrogen molecule remains uncharged. This bond in which there is no charge separation or polarity is called as non-polar bond. Now let us take another example of hydrogen chloride molecule. Here, hydrogen and chlorine are different atoms as they have different nuclei. These nuclei are going to exert different attractive forces on the shared pair of electrons which is present as a bond between these two nuclei. Chlorine atom has more attractive forces for the shared pair of electrons as compared to hydrogen atom. Hence, electron density will be more near the nucleus of chlorine atom. Due to this, chlorine atom becomes rich in electron density and hence acquires a partial negative charge. As the electron density moves away from the hydrogen nucleus, it has become electron deficient and acquires a partial positive charge. This results in the charge separation in the chemical bond of hydrogen chloride molecule. Hydrogen with partial positive charge, chlorine with partial negative charge, and that's how two poles are created in the chemical bond of hydrogen and chlorine, and this is called as a dipole. So, the molecule has polarity, the bond is polar, and it has a dipole. Now, what is a non-polar bond? In which there is no charge separation, no dipole. And what is a polar bond? In which there is charge separation because atoms of different elements are bonded to each other. There is polarity and a dipole. Okay, let's try some more examples. Hydrogen fluoride molecule and nitrogen molecule. In hydrogen fluoride, hydrogen and fluorine are atoms of different elements, hence there is a charge separation. There is a polarity, there is a dipole, and hence hydrogen fluoride molecule is a polar molecule with a polar bond. In nitrogen molecule, both the nitrogen atoms are identical. Hence, there is no charge separation And nitrogen-nitrogen bond is completely non-polar bond. The big question is about the charge separation. Why fluorine is acquiring a negative charge? Why hydrogen is acquiring a positive charge? As we have seen in the example of hydrogen fluoride, fluorine has more tendency to pull the shared pair of electrons on itself. The shared pair of electrons are spending more time closer to the nucleus of the fluorine, making it rich in electron density. It has a partial negative charge. Electron density has moved away from the hydrogen atom, so it becomes electron deficient, acquiring a partial positive charge. This tendency of fluorine to pull shared pair of electrons on itself in a chemical bond is called as electronegativity. So what is electronegativity? It is the ability or the tendency of an atom to attract shared electron pairs on itself in a chemical bond. In this example, fluorine is more electronegative than hydrogen. Let us work on hydrogen chloride molecule. In hydrogen chloride molecule, chlorine is more electronegative than hydrogen as it has more tendency to attract the shared pair of electrons on itself. Due to the difference in the electronegativity of hydrogen and chlorine, there is a charge separation in the chemical bond of hydrogen and chlorine. Hydrogen will be slightly electron deficient and chlorine will be slightly electron rich. Before we understand the reason in the difference of electronegativity, here delta means difference, En means electronegativity. So before we understand the reason behind the difference in electronegativity, I want you to be very clear about the meaning of electronegativity. Remember, electronegativity is the tendency and not the energy released or required. Electronegativity operates in chemical bonds and it is not in isolated atoms. These are the two important major points which we must know before we try to understand the basic difference in electronegativity and electron affinity. Let's pick up some examples to know the basic difference in electronegativity and electron affinity. In this example, B is more electronegative than A. Due to difference in electronegativity between B and A, the electron density is pulled more in the direction of B. This results in charge separation or the polarity in the bond. Whereas electron affinity or the electron gain enthalpy is the energy released. It is the energy released when an electron is added in an isolated neutral gaseous atom. So units of electron gain enthalpy is always in terms of joules or kilojoules, some energy unit. Whereas electronegativity is just a tendency. So it cannot be measured in joules or kilojoules or in any energy units. These are some points regarding difference in electronegativity and electron affinity which are worth noting down. Now we are going to discuss some questions based on the concept which we have discussed in this video. These are the simple questions. In the question number 1, they are asking us to identify non-polar bond and polar bond in the given organic molecule. This molecule has only two types of bonds, nitrogen-hydrogen bond and nitrogen-nitrogen bond. Now, what is a non-polar bond? When there is no charge separation. For example, A is bonded to A, both the atoms are identical, no charge separation. So this is a non-polar bond. Because atoms are identical, so the force of attraction on the shared pair of electron between these two atoms is identical. So electrons are not going to shift in any direction and they are equally shared by both the A's. In polar bond, we have two different atoms bonded to each other, and one atom is exerting more stronger attractive force on the shared pair of electron than the other one, and that results in the charge separation of minus and plus, and that's how the bond is classified as polar bond. Now this question becomes very easy after understanding these 2 points. Nitrogen-hydrogen bond, this is a chemical bond between 2 different atoms, so it's going to be polar in nature. And nitrogen-nitrogen bond, in this bond we have identical atoms bonded to each other, so this is going to be non-polar bond. In question number 2, they are asking you to identify most electronegative element in the given organic molecule. Most electronegative element has the highest tendency to pull the shared pair of electrons. Like if B is more electronegative than A, so this electron pair will be more closer to B. So B will acquire a partial negative. A will acquire a partial positive. Based on this, can you identify which atom here is more electronegative or the most electronegative? That is oxygen. Why? Because oxygen has a partial negative charge on it. It means it is the most electron rich after making chemical bond with carbon. So answer is oxygen bonded to carbon. Question number 3 is based on the definition of electronegativity. If we have a good understanding of electronegativity, then we can answer this question within seconds. They are asking us to fill in these blanks. It's a very important question. It's a part of many competitive examination. It can be asked in different format. So first thing you need to understand that electronegativity is not an energy. Because it is not an energy, so it means option 1 and 2 are out. And electronegativity is a tendency to pull shared pair of electrons. Now when we say shared pair of electrons, then it means it should be a chemical bond. It cannot be an isolated atom. So option 3 is out. So what is the correct option? Option 4 is the correct option, because we talk about electronegativity only in chemical bonds. A is bonded to B and B is more electronegative than A because it's exerting more stronger attractive pull on the shared pair of electrons. So we never talk about electronegativity in isolated gaseous atom. So the answer is 4. In this video, we did the difference in electronegativity and electron affinity. If you remember, we discussed one of the important difference as unit. Electronegativity has no units. It's a scale, which we are measuring in Pauling scale, whereas electron affinity has a unit. It is the energy released. So it means we have to pick up the answer which does not match with the unit of energy. So which answer is not matching with the unit of energy? That is ampere, because ampere is the unit of current. So it means only third option is correct, because they are asking us to identify which is not the unit, because calorie, electron volt and joules, all these are units of energy. So the correct answer is amperes. Question number 5 is based on our understanding in polar covalent bond. Which bond can be a polar covalent bond? A polar covalent bond is the one in which there is a charge separation, like A bonded to B, and B is more electronegative than A, so B is having partial negative and A is having partial positive. So there is a charge separation here. So nuclei of different atoms, they exert different attractive forces on the shared pair of electrons. That's the reason there is charge separation. So option 1 is out because they are saying nuclei of different atoms exerting same attractive forces. That cannot give you charge separation. Option 2, nuclei of different atoms exert different attractive forces on the shared pair of electrons. This is a perfect reasoning for the polarity in a chemical bond. Shared pair of electrons are transferred to one of atom in the chemical bond? No, there is no transferring of electrons. That's going to be ionic bond. Nuclear charge of both the atoms, if they have the same number of protons, then it means they are exerting same attractive forces. So there is no charge separation again. So the correct answer is option 2. Question 6 is based on our understanding of the term electronegativity again. If there is a difference in electronegativity, and if there is no difference in electronegativity. If there is a difference in electronegativity, there is charge separation. And the chemical bond is going to be called as a polar covalent bond. But if there is no charge separation, because the electronegativities are same, then the bond is called as non-polar covalent bond. Here they are saying atoms have exactly same electronegativity. It means there is no charge separation. So the bond is non-polar covalent bond. So that's the answer. Thank you for watching this video. We covered electronegativity part 1 in this video, and the following topics were covered with plenty of good examples and practice problems. Meaning of electronegativity, meaning of polarity of bonds, and what is the basic difference in electronegativity and electron affinity. In electronegativity part 2, we will be discussing factors affecting electronegativity like atomic size and closeness to the periodic table. We will also discuss the difference in electronegativities of the metals and non-metals. Click on this link given below to go to the second part of the electronegativity series. Links to notes and questions have been provided in the description below. Please like, share and subscribe, and do not forget to click on the bell icon to turn on notification.